Oh, this is number 4 from 7.7. It's 4 from the online work. It's 14 from the book. So to find the fluid force on the vertical plate submerged in water, where the dimensions are B equals 3 and A equals 9, given in meters, and the weight density of water is 9,800 newtons per cubic meter. So here's our shape the picture comes with. So I redrew this, and what we basically have is a square. All the sides are the same, so I'm assuming that all the sides are the same, so all the angles are going to be the same. And what we have is a 45 degree triangle on each side, or you can think from the bottom, from the side, whatever. So meaning the vertical part on the inside is 9 root 2 and the horizontal part is 9 root 2. It also means the distance from down here up to that red dashed line going to be, see if I can mark it somehow, from here to there, it's also going to be 9 root 2 over 2. Okay, so I'm moving on down here. I redrew it again. Now this line over here on the left side, on the right side, that line there, is defined by y equals x, so we could say x equals y. And we can say it's going to go from 0 to this line, or x minus 0, and just double it, or should say y minus 0. Up here for the other upper part, we know that this line is defined by, well, x is going to be 9 root 2 minus y. Gives us this one. And you could think of this as y equals 9 root 2 minus x, and solving for x we get this equation. Anyway, we'll say it goes from this to 0, which is a vertical line here, from there to there, and double it. So what I have done here, set up in our integral, 9,800 for the cubic, sorry, the kilograms per cubic meter, force per cubic meter, newtons. Well, there we go. Integral from 0 to 9 root 2 over 2, so we're talking about the bottom half. And the depth is going to be defined by, let me go back up here for this depth, come on, there. H of y, the height, is going to be 3 plus 9 root 2 minus y. So for the first part, we're going to go from 0 to 9 root 2 over 2, the halfway point. That's what we see down in the bottom here. So we see down here. Times the depth, 3 plus 9 root 2 minus y, times 2y. Why 2y? Because that's going from y to 0. We double it because it's symmetrical. dy. Integral, the next one, plus the integral 9 root 2, should say over 2. So from the midpoint to the top of this shape, it's 3 plus 9 root 2 y. So that's our depth part. That should be 9 root 2 minus y. Times 2 times 9 times root 2 minus y. That'd be this upper part, so minus, it's a 0. 9 root 2 minus y to 0, and then we do 2 to double it. And there's our basic integral setup. So our force is going to be 9,800. I'm going to bring the 2 out. 2 times 9,800 times what? If I bring this 2y through here, I'm going to have, what's the integral from 0 to 9 root 2 over 2. That's going to be 6y plus 18 root 2y minus 2y squared dy. Oh, I already brought the 2 out. Oops, I can't do that. So let me go back here, just erase. So it would be 3y plus 9 root 2 y minus y squared dy plus integral from 9 root 2 over 2 to 9 root 2. And I brought the 2 out already, so here we have a little bit more complicated stuff. So 3 times 9 root 2, it's going to be 27 root 2. 3 times y is minus 3y. 9 root 2 times 9 root 2, that's going to be 81 times 2, so 162. And then we have 9 root 2 times y. It should be minus 9 root 2y. And I'm out of space there. Then we have negative y times 9 root 2, so another minus 9 root 2y. And then we have plus y squared dy. Yeah. There we go. So 19,600 times what? We have 3y squared over 2 plus 9 root 2 y squared over 2 minus y cubed over 3 from 0 to 9 root 2 over 2 plus (27) square root of 2 times y minus 3y squared over 2 plus 162, messy, y minus 9 root 2, should be a root 2 in there, y squared over 2 and you know we have two of those 9 root 2 y squares over 2, so what if I just did away with the squared part, or the over 2 part, and then we have a y cubed over 3. And this is going to go from 9 root 2 over 2 to 9 root 2. Okay. So our force is going to be 19,600 times what? Now, to clear this up a little bit, that's going from 0. So 3/2 times 9 root 2 over 2 squared plus 9. You know something? I'm just going to start this over on the next page because it's not enough space. So force equals 19,600 times 3 times 9 root 2 over 2 squared, is 3/2 that, plus 9 root 2 times 9 root 2 over 2 squared over 2 minus 9 root 2 over 2 cubed over 3. So it's interesting, we have a 9 root 2 times 9 root 2 squared. Interesting there. And then we will have a plus. Nice if I could see that part. This next line is going to be quite long and messy. (27 root 2 times 9 root 2 minus 3 halves 9 root 2 squared plus 162 times 9 root 2 minus, come on, draw, minus 9 root 2 times nine root 2 squared, and then we have plus y, not y, 9 root 2 over 2, or 9 root 2 cubed over 3. There's a 2 there. Minus 27 root 2 times 9 root 2 over 2 minus 3 halves times 9 root 2 over 2 squared plus 162 times 9 root 2 over 2 minus 9 root 2 times 9 root 2 over 2 squared plus 9 root 2 over 2 cubed, and divide that by 3. Okay, put all this fun stuff in the calculator, and we should come up with 396,900 times 9 root 2 plus 6 newtons. Okay, and that would be the end of this problem. A lot of work for that one.